Introducing question 3, probability. Okay, so we got, it looks like binomial, they're blue or they are white. So we've got a sample of 5 bags and bulbs are sold in mixed bags of 40. Find probably that fewer than 2 of these bags will contain no more that grow into blue than grow into white. Okay, so let's have a look at one bag. One bag, and let's say blue is distributed binomially, so 0.36 it's BNP, isn't it? So we've got bags of 40 and the probability of being blue is 0.36. So we're looking at bags that can contain more bulbs that grow into plants with blue flowers. So we want the probability that B for bag. Okay, okay, fine. Let's say B for bag. And this is blue bag. Let's say blue bag. So blue flowers, we want more. Okay, so bigger than or equal to, was it strictly more, isn't it? That these bags will contain more bulbs, so bigger than or equal to 21. That's more, isn't it? Which is 1 minus the probability BBA is less than or equal to 20. Then we can use our calculator. So let's have a look. So we're going into menu, 7 distribution. We're going to go down. We want to use binomial CD. Can you see that? How clear is that? I mean, might as well just use variable for this one. Binomial. So x is equal to 20, n is equal to 40, p is equal to 0.36. Hopefully you can see that. Let's see how can we get that. Just about. And so we got 1 minus 0.97599, which is equal to 0.02401. Okay, to lots of decimal places. That is the probability that one bag has more blues. And we want the probability that fewer than 2 of these bags we can have. Okay, so now the bags with okay, so more blues, that's looking at the bags, is distributed binomially, and we've got 5 bags, and the probability that one of them contains more blues is 0.022%. It's not much, is it? It's not much, but then it's, you know, it's more likely that you're white, and we're wanting more blues, so it makes sense. Okay, so more blues is binomial 0.02401. I'm going to say 1 minus answer. Can we do that? Okay. Fewer than 2 of these bags. So we want the probability that MB is strictly less than 2, which is equal to probability of MB, because this is a discrete distribution, is less than or equal to 1. What I'm going to do as well, just, you know, showing off what we can do this, right? Let's get that display. Can you see that all right? Yeah. Okay, so I'm going to save that alpha A. Oh, okay, I'm going to go menu 1 minus ans. Okay, that's that. And then store A. So I've stored that 0.02 as A. Then I'm going to go back to my distributions, go back to normal CD, go back to variable. Now this time X is 1, N is 5. P I'm going to put in as A, because then it's like loads of, see that? Hopefully that comes out. What's that? Okay. Just way of using the calculator. And we get P is equal to 0.024. So that's your answer, which is really interesting, because that's the same. Oh no. Okay. 0.9945. There you go. So it's really likely. Okay, I'm probably fewer than 2 of these bags will contain more. Okay, fine. Maggie takes a sample of n bulbs using a normal approximation. The probability that more than 245 of these bulbs will grow into blue flowers. Ooh, normal approximation. So that's a good one, isn't it? So we want to find the probability. Okay, so we've taken n bulbs. That 244 of these n bulbs will grow into blue flowers. Okay, the probability that n is bigger than 244 is 0.0521 to 4 decimal places. Find the value of n. So, blue flowers. So we're back to blue flowers, aren't we? So blue is distributed binomially. Blue is distributed binomially. N, and the probability of being blue is 0.36. And it's really big here, and we're quite close to 0.5. So n is big. Well, it's bigger than, definitely bigger than 244, right? And p is quite close to 0.5. So we can use our normal approximation. So probability that n is bigger than 244, it says that, isn't it? More than, not more than or equal to, more than. Okay, that's the same as saying probability that n is bigger than or equal to 245, because remember, we've got okay, so actually I think we want the probability that number of blue ones is bigger than 244, isn't it? Blue is distributed binomially, n 0.36, that's it. Number of blue ones is bigger than 244. So that's number of blue ones is bigger than that. So that's discrete, isn't it? Because blue is distributed binomially, so that's discrete. And we want to use, it says using a suitable approximation, a normal approximation, sorry. So we need to do a continuity correction. So that becomes probability blue is bigger than or equal to 244.5, because that will round up to 245, won't it? If that's small. So yeah, we want that. We want to make the space bigger. So if you want that on a number line, we're going to have 243, 244, 245, 246, 245, bigger than or equal to that, right, which is all of these, but that 244.5 is going to round up to that. So yeah, we got that. Okay, so that's what we want. We want to work out probability that blue is bigger than that. So do we know our mean or our standard deviation? Let's have a look. What are we working out? We're trying to work out n, and we know, so blue normal is distributed, let's say blue normal approximation is distributed normally, mu sigma squared. If you remember our approximation, that is np 1 minus p. That's our approximation. So here we've got 0.36 n, because that's our n, that's our p. What's 0.36 times 0.36, hang on, 0.36 times 1 minus 0.64, which is
0.2304n. So that's our, okay, so standard deviation is square root of 0.32304n. So we got that. Mean in the middle there is 0.36n. We've got 244.5 there. We know it's bigger than, we know it's going to be down here because it's a tiny probability, and that in there is 0.0521. Is that all of that on the page? Okay, so there we go. That's what we're looking at. And that's our blue normal axis. What was that axis down there? Right, so what we're going to get, remember, Z is equal to minus mu over sigma. So if we use our inverse normal to get this Z value, so menu 7 inverse normal, area is 0.0521, sigma is 1, so I'll write this down. Remember, Z is distributed normally. Is that all on the page? Yeah, normally 0, 1. So we've got area is equal to 0.0521, sigma is equal to 1, mu is equal to 0, so it's the z-axis, isn't it? And we get, why is that giving, oh, it's giving us the z value of minus 1.6248, but obviously we want the positive one, 1.6248. Okay, so we got that. That's our z value, 1.6248. Why is it obvious? Because it's a number line, right? We've got 0 here. That's why the picture's so good. Okay, is equal to our 244.5 minus our mean, which is 0.36n, divided by our standard deviation, which is the square root of 0.2304n. Wowzers. I mean, there's still some work to do. Can we go, just to keep it all on, let's go up here so it's all on one page. Continued. So we're going to have, this is just going to give us a quadratic, isn't it, to solve for n. We're looking at, which is fine. It's not going to give us a nice quadratic. So 1.6248 times root 0.2304 times root n is equal to 244.5 minus 0.36n. Right, if we square both sides, I've got that number saved. Menu 1 answer equals, yeah, so square that. So we're going to get 2.64 times square this 0.2304 times n is equal to this squared, which is going to be 244.5 squared. 0.27 minus 176.04 n plus 0.36 squared. I feel like this might be a bit tricky. 0.1296 n squared. Bring everything to one side. We bring everything to one side and we've got a quadratic, haven't we? Okay, so we get 0.1296 n squared minus 176.04 n minus this again. Hang on. 0.264 times 0.2304. So we got that many n and that many n, but minus, so 0.1. Let's just do it to one decimal place. 0.1 n plus 59780.25 equals 0. Okay, let's put that, so n is equal to, let's just put that in the calculator. So what's our quadratic? It's going to be equation polynomial degree 2, right? A is 0.1296. It seems a lot, doesn't it? Minus 176.1, 59780.25. Okay, so we get 697.13 or 661.66. I don't know. I don't like that. No, that can't be it, can it? Can't be it, because let's have a look. That let's say 661 times 0.36, which could give our mean 661 times 0.36. It's going to give a mean of, well, it could be that gives us a mean of 237.96. It could be. Yep, one of those. Which one though? Find the value then. I mean, they both seem reasonable, don't they? What about this one? What about 697.13 times 0.36? Let's have a look at that. 697.13 times 0.36 is equal to 250, which is too big. Okay, so we got our answer. Isn't it? Okay, well, let's see what you guys get.